Alright everybody, this is section 2.1. This is strictly right triangle trig, so this is back to kind of geometry days where we had SOHCAHTOA. Hopefully this is relatively not necessarily new, and hopefully we can do well with it. Like I said, the SOHCAHTOA, how this works in your triangle, we've already talked about this, but if this is your angle, your sine, cosine, tangent directly goes off of this. So we know now that sine is y over r, or your opposite over hypotenuse. We know cosine is x over r, or your adjacent over hypotenuse idea. So all of that should be straightforward for the SOHCAHTOA. Alright? So what I want us to think about, if you want to think of SOHCAHTOA, or you still can think of the y and the x idea, but this might be a little bit easier now using the SOHCAHTOA mindset. So if I want sine of angle A, so if I use this triangle, angle A will be down here. Side A is always across from angle A. Side B is always across from angle B, and side C is always across from angle C. So it's kind of important notes to take as we get through this section. So on this particular triangle that's set up, what is sine of angle A? Sine is the opposite over hypotenuse. Opposite angle A is little a, divided by hypotenuse, and the hypotenuse is going to be C. Okay? So now if you want to do, I usually do the three main ones first, sine, cosine, tangent. Cosine, adjacent over hypotenuse. Cosine of angle A, the adjacent side is B, the hypotenuse is C, so it's B over C. And the tangent of A is just going to be opposite, which is A, over adjacent, which is B. And then how do you obviously find the reciprocals, or the ones that match? So cosecant, you just flip it. So in this case it's C over A, C over B, and B over A. So hopefully that's not necessarily anything new. Now when you end up finding sine of angle B and you're going to use the same picture, opposites and adjacents flip-flop. So you have to be careful on that. The opposite of angle B now is going to be the side across from B. So it's going to actually be B over hypotenuse, which is C. Okay? Notice that sine of angle B is the same as cosine of angle A, so we're going to kind of see a relationship there. Then the cosine of B, adjacent now becomes A over hypotenuse, and tangent of B, alright, tangent is going to be opposite, which is B, over adjacent, which is A. And then you obviously can just flip them to find the other one. So this is C over B, this is C over A, and then this will be A over B. Now that is strictly using that particular general triangle. Now in this section we're going to throw numbers in there and maybe have you solve triangles, and that's kind of the goal. So here's an example of this. I might give you a few pieces of information and you're the one that's going to have to put them in there. So if I say triangle ABC, all that means is you need to put A in one spot, B in another spot, C in another spot. They're going to tell you which one is the right angle. So that's the 90-degree one. That's why I labeled that C. You hypothetically could flip-flop these two. That's your choice. It does not matter. Okay? Just know that when you put side A on the graph or on the picture, that has to be across from your angle A. It does not matter where you set it up or how you do it. Just make sure the 6 is across from angle A. And then obviously if C, little c is 10 or side C is 10, that's got to go across from angle C. Okay? And it says find the 6 functions of A. So in order to do that, you need to have all three sides. So how would you find side B? Hopefully you're thinking to yourself, sweet, this is a right triangle. I have two of the sides. I can use Pythagorean theorem. Now a lot of you can look at that and know that it's probably 8, but we're going to set up Pythagorean theorem anyway. Okay, so it's 36 plus b squared equals 100. Subtract the 36. So b is 60, or b squared 64. And then b equals plus or minus 8, but since it's a side length, it has to be the positive 8. So I know b is positive 8. And now you can go through and do your trig functions for angle A only. So sine of angle A, opposite. So that's, I'm looking at this angle right here. Opposite of A is 6 over 10. But that reduces to 3/5. In trigonometry, you always want to reduce. No ifs, ands, or buts about that. Okay? So cosine A will end up being 8 over 10. Now I'm just going to jump, I'll write it down. 8 over 10 will reduce to 4/5. And then tangent of angle A will be what? 6 over 8, opposite over adjacent, which reduces to 3/4. And once you find the three main ones, the other ones are quite simple. So I know that cosecant of A equals 5/3. I just got to flip it. Secant of A is 5/4. And then cotangent of A is 4/3 simply by flipping the original 3. Because they're reciprocals of each other. So that's what you do if I give you information about one angle and then you only have information of sides. That's what you need to do. You just set up your triangle, find the other side, and then you can find all your trig functions. Okay? Here's the fun part. Okay? Cofunction identities. Alright? Now these cofunction identities are on your salmon sheet. It says cofunction formulas on the very bottom left. So if you have your salmon sheet, you should go there right now. Okay, but here's what's happening. A plus B, if A and B are equal to 90 degrees, so when you add them together they're equal to 90 degrees, the following are true. Sine of angle A will be the same as cosine of angle B. And then your secant with your cosecant, your tangent with your cotangent. Okay, so they're going to actually equal each other. And we kind of notice this here. Cosine of A is the same as sine of B. And vice versa. If you look at those relationships, that's going to be true every single time. Okay? So how does this work? So if I look at this, if I have cosine of 30, that's going to be equal to sine of what? Remember, A plus B must equal 90 degrees. These are called cofunctions. They work with each other. So this is going to be 60 degrees because 60 plus 30 is 90. Okay? If I say plain and simple, let's jump down to this one because it's a number. 75 plus what gives me 90. So that's 15 degrees. Alright? Tangent y is equal to, what's cotangent going to be? Okay? And all you do there is insinuate that it's going to be equal to 90, but I don't know what y is, so I have to go 90 degrees minus y. Okay? So that's the cofunction idea in a nutshell right there. Okay? Now, this can be anything. It can relate to secant of 33 degrees, for instance, can equal cosecant of 57. They don't always have to be nice numbers. It can be something as crazy as sine of 1 degree. It's simple as small as 1 degree is the same as cosine of, hopefully you're thinking, 89 degrees, because these two numbers need to add up to 90 degrees. That's the idea of cofunctions. Okay? So when we get into our 30, 60, 90 triangles, the same thing's kind of happening. Okay? So when we set this up, and this is what we're going to want to jump to, if you have a 30, 60, 90 triangle, hopefully you can know, okay, opposite 30 is 1, opposite 60 is root 3, your hypotenuse is 2. If I get the sine of 30 degrees, I know it's opposite over the hypotenuse, right? So if it's opposite over the hypotenuse, it's going to be 1/2. Cosine of 30 degrees is going to be square root of 3 over 2. And then tangent of 30 degrees is going to be the whole 1 over root 3. But then I got to do the root 3 over root 3 thing. So it's end up being root 3 over 3. Okay? So I know that that's kind of the case. But now what should happen? If sine of 30 is 1/2, using the cofunction idea, that should be the same as cosine of 60. Now if I look at 60 degrees, how do I figure out cosine? What's my adjacent? It's 1. It's talking about the same side over 1/2. That's why that works. Okay? The sine of 60 should be the same as cosine of 30. Alright, so what's sine of 60? It's opposite over hypotenuse. So it's not necessarily anything brand new in this scenario. It's just a fact of, okay, and the tangent of 60 is square root of 3 over 1, which is just this guy, you know, flip, but it's just a different idea. I don't have cotangent on here. If we did all 6 of them, you'd say the relationship in that. And then also, cosine of 45, we all know it's 1 square root of 2. So when I go 1 over square root of 2 and do the root 2 over root 2 thing, it's square root of 2 over 2. Now, hopefully you've recognized now that sine of 45 and cosine of 45 are the same thing because of the cofunction relationship. Okay, and tangent 45 is just 1 over 1, but we're not going to talk about cotangent. So that's kind of the idea. You need to recognize and be able to do these. Now, when I say know these, should you memorize them? Yes, it would be helpful if you did. And the more you use it, the more you're going to know. Sine 30 is 1/2. cosine 30 is square root of 3 over 2, and so on and so forth. I mean, the more you do it, the easier that will become. But are you still able to draw these pictures on your paper? Absolutely. Anytime you want, you can draw those pictures and use them to your advantage. Okay? I apologize, Mr. Brody decided to try and interrupt me. So anyways, here we go. Use exact values from the previous page to show the following are true. So what you need to do here is if you give an equation where you say show that something's true, it's going to be true. You just got to figure out how to do that. So when you see cosine squared of 30 degrees, this is exactly the same as cosine of 30 degrees squared. Remember our shorthand in trig with the square comes inside. Okay, so you need to go back to your triangle and say, okay, what's cosine of 30 degrees? Well, it's square root of 3 over 2. So I know it's going to be square root of 3 over 2 squared. Alright, and then we have to go plus sine of 30 degrees. If you flip back to your other page or look, it's 1/2. So 1/2 squared. How is that going to equal 1? Well, if you distribute the square to both, root 3 times root 3 is 3 over 2 squared is 4 plus 1 squared is 1, 2 squared is 4. What's 3/4 plus 1/4? 1. So that's how you show that something's true. Likewise, this is going to be cosine 45 quantity squared. Well, we know that cosine and sine of 45 are both root 2 over 2. So root 2 over 2 squared plus root 2 over 2 squared. And then if you distribute, once again, square root of 2 squared, root 2 times root 2 is 2. 2 squared is 4 plus 2/4 plus 2/4 is 1. Okay, so that's as simple as it is. You're going to go through a bunch of those where you just need to pull in what the relationship is and actually do the mathematical equation. So it's relatively easy. Here's a little bit more difficult, but you just got to read the directions. It says let x be 30 degrees. So wherever you see an x, you put in 30. Let y be 45. So wherever you see y, you put 45. And then you just simplify each of them. Okay, so this is going to be 2 times sine of x, but what is x going to be in this problem? 30 degrees. And then you got to go back to your special triangles. The more you work with it, the better you are. But sine of 30, if you go back to the other slide, is 1/2. 2 times 1/2 is 1, and you just solve the problem. So sine of 2 times, what's y? 45 degrees. So now we end up 2 times 45, sine of 90. Well, what's the sine of 90? You got to think back to your quadrants. 90 is straight up. The 0, 1 idea, x, y. Sine is y over r, so it's going to be 1 over 1, or strictly 1. Okay, and then you might see something crazy like this. Well, don't let it scare you, because something nice usually happens. That's what happens in trig, and I'm really nice like that. So it's 3 times x, which is 30, minus 90. So it's 4 times sine of 90 minus 90. So 4 times the sine of 0 degrees. Well, what's the sine at 0 degrees? If you draw your picture, 0 degrees is straight to the right. 1, 0. The y value is 0. Y over r is 0 over 1. So 4 times 0, it's just 0. And it might look like something like that. So that is section 2.1. It's right triangle trig. Those are the problems that you're going to see as we work them together in class tomorrow. So I hope you have a wonderful day.